All right, integration by parts. Are you guys ready? So first, let's do a little bit of rearranging so you can see where this integration by parts come from. We're gonna just do the product rule with this. So I have u times v, so that's, what is the product rule?
So first there's the second plus second derivative.
Yes. Do that, guys. Do that first.
What are the opposite?
That's fine. All right, so now what I want, I'm looking at the integration by parts formula down here, so I can see what it is. So what I'm going to do is I'm going to move this guy to the left, and I'm going to rewrite it with this guy in front. So I'm going to write u dv dx equals d dx of uv minus v du dx.
Oh, wait, why did you say du dx on the first one, but just ddx on the second?
Oh, because I'm finding the derivative of that, right?
Oh, wait, so like you rearrange the equation.
Yeah, just rearrange
So
it.
it was like ddx of uv, you subtracted v from that side.
Yes, that's a u right.
Wait, oh. Wait, so that's u dv dx?
Oh yeah. U dv dx. My bad. U dv dx.
Wait, why did you put the equal sign?
That equal sign is this equal sign. I moved this to the left, and I wrote this first, and then d dx of uv minus v du dx. Nothing crazy, right, guys? Okay. No, you're good. You're good. And then what I'm gonna do is I'm gonna integrate and put dx. Whatever you do to one side, you do to the other. And then here's what happens. So this guy turns to integral of u dv equals, I'm taking a derivative of the integral, so that's just going to be uv. I put it in there because I integrated.
Oh.
And this guy here, and I know this is not like a super awesome formal proof. This just turns to integral of v, the dx's cancel out, du. And this is what you call, the only reason we did this is so you can see that so we're not robots, so you can see it comes from somewhere. This is called integration by parts. And it can be derived from the product rule. Yay or nay? Okay. It's another tool to know how to integrate. So it's just like long division and all that good stuff. Come on, Romero. Focus, miss. I know, but I think like you're trying to do two things at the same time, and I need you to really focus because I want you to, I'm trying to give you I want to offer the best education, miss, and I want you to get it. And I know you'll get it eventually because there's so many examples out there, but All right. Are we okay with this? Cool or not cool? All right, so like Abdul Karim said, when am I going to use this? Well, anytime you're integrating, if you can't do u substitution, if you can't do, have we done partial fractions yet with you guys? If you can't do partial fractions, that's another one that we have to learn. If you can't do long division, then resort to integration by parts. And it does come out in the free response very, often. All right, so look at this one right here. You see this x cosine x dx? When you guys were in AB last year, you could not do it. And I think I remember saying like, oh yeah, we can't do it yet, guys. You got to know integration by parts. Do you remember when I would say occasional stuff? Okay, but now you can. So on integration by parts, what you're going to do is you're going to choose a u, and you're going to choose a v, or actually a dv. So see how this says u dv? So the u, I'm going to make, and sometimes it's trial by error, and you got to just see what's up. But let's make the u equal to x and see what's up. If u is x, then that means du is just dx. And then we're going to make the cosine x dx be the dv part. So I'm going to write cosine x dx. And let's see if this one works. So if dv is cosine x dx, then that means v was sine x. Are we okay so far?
Yeah.
So then I write integral of x cosine x dx is nothing more than, and it says uv, so I plug in what u and v is, x sine x. And then it says minus integral of v du. So I write sine x dx, and it looks like it worked out perfectly. And there it is. And then I just do, what is the antiderivative of sine x? Negative. Negative times a negative? Positive. So I'm going to have integral of x cosine x dx just equals x sine x plus cosine x plus c. And that's it. Now, of course, it gets more complicated, but we started off with a simple one. Yes, ask. That's the UV part. How do we feel? Do we feel okay, guys? Yes, ask. Yeah, I could have chosen sine x. I should have chosen cosine x as x. I didn't choose v. I chose the dv, and when I went backwards, it gave me sine x. Do you know what I mean? Yeah. You got it down, Abdul Karim? Okay. Yeah, sometimes you got to do something called tabular method, but we're not there yet. We have to wait until we're more advanced. All right, here we go. We're just doing, so I give you a little trick here. The acronym is LIPIT. It's also in your textbooks, but we don't use textbooks. Delta Math, I don't know why I called it Delta here. Delta also uses LIPIT as the acronym, so they probably took it from the Demana textbooks. So LIPIT stands for this, all right, LIPIT. These are like what you should try to use, what you should try to make U first. L stands for logarithmic. I stands for inverse. P stands for polynomial. E stands for exponential. And T, take a guess. What do you think T stands for? Trig. These are the orders in which you should try to make U. And relax, it doesn't always work. It's not 100% bulletproof, but this is just like a common rule that you should try first. All right, so I have this here, and I'm gonna say, okay, what is my U? And what is my dV? Because that's what you're assigning. And then from the dV, you go backwards to V. So according to this LIPIT here, let's see, do I have a logarithmic? No. Do I have an inverse? No. But do I have a polynomial? Yeah, so make the x squared the u. So then du it becomes 2x dx. So then that means e to the x dx is your dv, and v becomes e to the x. Do we see what we did? So here we go. I'm going to go slow, guys. So the integral of x squared e to the x dx equals, and it says, if you look at your rule over here, it's uv minus integral v du. So I write uv, so x squared e to the x minus integral of v du. So e to the x 2x dx. You can put the 2x in the front as well. Now, did we get better? Yes, we did. Because notice, originally I had an x squared, and now I have a 2x, so it's simpler. So we're going to do u sub again. We're going to do integration by parts again. So I'm going to circle this. And I'm going to say again. What again? Integration by parts. That's why it says repeated. So I'm just doing that blue. So notice I'm color coding it here. So I'm just doing that color code here in blue. My u is going to be 2x. So du is going to be 2dx. V. Say it again. Because if you tried u, okay, so don't write this down, just listen. If I try u to be e to the x, look what happens. Then that means my dv is 2x, so then that means my v is x squared. So when I do my uv, don't write this down, this is all wrong. E to the x squared minus v du, x squared e to the x dx. Did it get simpler or did it get more complicated? It got more complicated. If I would have done that over here, if I would have set u equals e to the x and dv equals x squared dx, I would have had an x cubed. And you're never going to get to a point where you can reduce it. because you're just getting larger and larger. Does that make sense? All right, what's up, Marcello? Yes, because she told me to start from here. If I would have started on this one, it would have been a cubic. It would have been it would have been 1 degree higher. You know what I mean? All right, so let me write the correct U and the correct dV. So what did we say that U was? Oh, what was the question, Ramirez? I saw you lift your hand.
I think no, no.
Okay. So here we go. So this is just for what I circled in blue, guys. So UV 2x e to the x minus integral of v du. And now look at this. Isn't this way easier to integrate? Okay, I'm coming back. I'm putting it all together. So we should have enough space. So I'm going to write, so here we go. Integral of x squared e to the x dx equals, and I start right here, right? X squared e to the x minus what? All this here. So minus 2x e to the x plus 2e to the x, and then don't forget, you don't have any limits, so I write plus c. Nope, nothing's combined because there's no like terms. How do you feel? Cool, right? What is this called? Integration by parts.
Okay.
All right, let's go to the next one. All right, look at this one. So again, we're going to do with our little lipid thing. And we say, okay, logarithmic, no. Inverse, no. Polynomial, no. Exponential. So then I guess the u is going to have to be e to the x. Du is e to the x dx. And then v and dv. So the cosine x dx has to be my dv. And your v has to be sine x. I'm gonna go integral, and I'm gonna go slow because this is a little different. E to the x cosine x dx equals uv e to the x cosine x, not cosine, sine x minus integral of what? V du. So sine x e to the x dx. I'm gonna write e to the x first. E to the x sine x dx. And then so maybe you're realizing something. You're like, man, this looks like it's just going to be going back and forth. Because notice we had e to the x cosine x, and this is e to the x sine x. But that's okay if it goes back and forth for this one. Because then, if I do it again, look, notice that I'm circling this. This is what I'm going to do u sub again. I keep saying u sub. Integration by parts again. So I'm going to write u equals e to the x. Du equals e to the x dx. V and dv. dv is going to be sine x dx, and v is going to be positive or negative? Negative cosine x. Here we go. I'm just doing that. Just this one right here. So uv, so negative e to the x cosine x minus integral of v du. So minus that negative, so it's going to turn to a plus. E to the x cosine x dx. And here's where you should stop. Well, it's minus, but this is negative, so minus a negative turns to a positive.
Oh.
I'm just doing that color, whatever I circled. All right. Hopefully by now you're seeing, hey, look, I have the same thing again. That's a good thing because now we can just do algebra with it. So here we go. I'm going to put the whole thing. So I'm doing the whole thing now. Integral e to the x cosine x dx equals e to the x sine x minus, so minus on minus, it turns to a plus, e to the x cosine x minus integral, I distribute the negative, right? E to the x cosine x dx. I don't see any mistakes. Okay, I don't see any mistakes. Do you guys? Yes. Take this, move it to the other side. How many do you have? No, not 0, because that's a negative 1. So when I move it to the other side, it's...
Oh, you're adding
so 2. So 2 of these. E to the x cosine x dx equals e to the x sine x plus e to the x cosine x plus c, I guess. Well, it doesn't matter. You know what? I'm going to put the plus c last because it doesn't matter. All right.
Wait, why is it plus e to the x plus
That one is that one. That one is that one. When I moved it to the other side, it turned positive. And are we okay so far? Any questions? The only thing I got to do is get rid of the 2. How do I do that? Divide by 2. So the integral of e to the x cosine x dx equals, and I'm going to write it like this, 1/2, I'm going to factor out that e to the x, parenthesis, sine x plus cosine x, close it, plus c. You can actually put the plus c on the inside if you want, but I'm going to leave it alone right there. And there it is. What'd you guys think of that one? Ask. I put a 1 where? Where? I mean, are you talking about this one? You can. I mean, -1 of that. Oh, yeah. Oh. Sine x plus cosine x is not a property. Okay. Yes.
How do you know when to stop? Like right now,
That's it. You stop because you wanted to know that.
well, right now, we gotta stop because we want to. Like in the future, we're just supposed to
You do one integration by parts, and you're like, I have e to the. Don't worry, I see what I mean. I see e to the x cosine x. Now I have e to the x sine x. If I do integration by parts again, I'm going to get e to the x cosine x again. Oh wait, I have e to the x cosine x over there. I can move them, add them together, and then I can do some algebra. You know what I mean? What's up? Yes, that's the same thing. And then you got to put the plus c somewhere though, right? Okay. All right. And next example, ln x. LIPET. We have a logarithm right off the bat. U equals ln of x. Du equals 1 over x dx. V and dv. dv is equal to dx. So v equals x. Are we still okay? All right, here we go. Integral of ln x dx equals uv. So x ln x minus v du. Integral of x times 1 over x dx. Oh, it's beautiful. This one works out beautiful. So x ln x minus integral of 1 dx. I guess you don't have to write the 1 if you don't want to. The x's cancel out. So let's see, integral of ln x dx equals x ln x minus x plus c. Are we okay? Right. Yeah, nothing's hard, miss. Yeah, that's it. That's it. You're done. Remember, when do you use this? If you can't do U sub, if you can't do long division, then it must be integration by parts. There's also another one, partial fractions. We'll get to that one because that one is also pretty common. All right. Again, we got LIPET, our little acronym. And it's not a logarithmic, but I do see an inverse. So U is arc sine of x. Hopefully you guys remember what the derivative of that is. V and dv, so dv has to be dx. All right, what's the derivative of arc sine? 1 minus x squared. And then don't forget your dx there. And then dv means that dv has to be dx, so then v has to be just x. All right, here we go. Integral of arc sine of x dx equals uv. So x arc sine of x minus integral v du, integral x over square root of 1 minus x squared dx. And I'm going to slow down. So now if you have colored pencils, there's a good location. This I can do, but I'm not going to do integration by parts anymore. What am I going to use? U sub. What is U going to be? Yeah, 1 minus x squared. So du equals negative 2x dx. So I'm going to take a different color. I'm going to add that in there to balance it, right? Chemistry. I'll put a negative 2 right here. I'm going to put on the outside a negative 1/2. Are we still okay? So now I have this. That turns to a plus. So now I have, let's see, I'm just doing this, so I'm going to put it in sky blue. So let's see, I have plus integral 1 over u to the half du. So if you bring that up, integral u to the negative half du. So it's going to be add 1 divided by that number. U to the half divided by half, so that's 2 plus c. And I'll slow down. I plugged in like 1 minus x squared is u, right?
What happened to the half?
I brought it up. So negative half.
No, the half. Oh, like the half that you put on the outside, the half.
Oh yeah, it should still be there. So what's half times 2? 1. Okay, so here's my final answer. Integral of arc sine x dx equals x arc sine x plus square root of 1 minus x squared plus c. I don't see any mistakes. How do we feel? All right, so all you're doing today is just practice. Oh, ask.
Wait,
Did I make a mistake?
never mind. I thought the 1/2 was negative.
It was, but I have a minus right there. Minus a negative turned into a positive right there. See? Well, I put in a negative, right? I put in a negative 2, so then I put in a negative half, but I already had a minus.
Talking about the
Oh, what a,
like the exponent using like the half the square negative square.
that's negative. And then when I added 1 divided by that half, right? I don't think yeah, I added 1, so it turned to a half.
It would be negative square root because
When you bring it up,
when you divide by negative half,
what?
right?
Yeah, so in the bottom I have square root of u, right?
Yeah.
Which is u to the half, but when I bring it up, it's u to the negative half, and then I add 1 to the exponent, divide by exponent, so there's my 2, but I still have this half here. Half times 2, so that's just u to the half. Yeah, maybe we'll do that on Friday. Well, maybe you'll get some review right now. Cool or not cool?
Okay, wait, I'm not looking at the board. Was the final answer X,
We'll check right now if we're correct with Wolfram Alpha.
plus 1 minus... Okay, yeah, I've heard that.
All right, let's check if we're correct. All right, here we go. Check it out. You go to Wolfram Alpha. I love Wolfram Alpha. I even have a subscription to them. And then I put integral. Bam. And then what was it? Arc sine? So arc sine x. And then I put x, and then I put enter. And hopefully they'll give you the same thing that we got. Now check it out. We did good. We got the same thing. Square root of 1 minus x squared plus x arc sine x plus some constant. Isn't that cool that we have all this technology that does all this for us now? You don't think that's cool? I think that's really cool. All right, guys, so I have some Delta Math. I put all the easy ones, all the ones that are related to today's topic. And all you're doing is practicing doing this over and over. There's only 12 questions. Thank you. Give it a thumbs up and subscribe if you liked it.